Hi, in this video we are going to talk about the SEM process. But what is SEM? SEM is an umbrella term, so structural equation modeling, that is used for a wide set of analyses in order to identify patterns of relationships between various theoretical constructs. Its main strength is that it combines regression models with factor analyses. In fact, each of these can be seen as a special case of SEM. The SEM process has multiple steps. First, you have to specify the theoretical model. Then you have to apply the model to the data. Then you have to check if the model fits the data. And then you have to check the strength of relationships. Finally, you will probably want to revise and refine the model until you reach a version of it that you are satisfied with. So let's take each of them in turn. In the first step, you have to specify the theoretical model. This means you have to either read the existing theory or develop a new theory. And then you have to formulate your hypotheses. It's always extremely helpful to draw a diagram. This can always help remind you of all of the relationships you will want to specify in the model. In the second step, you will want to apply the model to the data. So for this you have to link your dataset to MPlus, then carefully lay out all of the relationships, and then you have to just press run and hope your model will work. When you apply the model to the data, you use some information based on your current dataset. From your dataset, MPlus will extract a correlation matrix or a variance-covariance matrix. In some cases, it will also include means and intercepts. A correlation matrix is like a correlation table. So each of the cells will show the correlation between a pair of variables. The variance-covariance matrix is very similar to a correlation matrix. In each cell, instead of the correlation coefficient, you will have the covariance between each pair of variables. On the diagonal, you will have the variance of each variable. So with this, you have the data variance-covariance matrix. For the model, you then have a set of parameters. That is because you request MPlus to estimate things for you, such as the regression coefficients, means, correlation coefficients, factor loadings, and so on. After your requested parameters have been estimated by the model then computes a hypothetical variance-covariance matrix. So now you have two matrices, one from the data and a hypothetical one produced by MPlus. So in order to see whether your model fits the data, there will be a comparison between the two. However, you don't have to do this yourself. MPlus will do that comparison for you. What you do have to do in order to check if the model fits the data is to look at the model fit indices and see whether they make their respective thresholds. The first one is the chi-square test of model fit. You will want this value to be as small as possible because that means that your hypothetical model does not depart significantly from real data patterns. So therefore, you will want the p-value of the chi-square to be non-significant. However, when you have a large sample, the chi-square will almost always be significant, leading you to erroneously reject your model. For this reason, researchers have developed another set of fit indicators. MPlus will output this, and in fact what you see here is an excerpt from an MPlus output. The first one of these indicators that you should look at is the RMSEA, the root mean square error of approximation. You will want this value to be as small as possible, as close to 0 as possible. But you will definitely want it to be below 0.06 or at the very least below 0.08. The RMSEA comes with a 90% confidence interval. You will want this confidence interval to be very narrow, because that means you have quite high precision and quite high confidence in your RMSEA estimate. And you will also want the upper bound of the confidence interval to be at least below 0.08, or even better, maybe below 0.06. The next set of model fit indicators are the CFI and the TLI. The CFI stands for Comparative Fit Index, and the TLI stands for the Tucker-Lewis Index. They both have thresholds of 0.95, and in this case you will want those values to be at least 0.95. Previous thresholds for these were 0.90, so some reviewers still accept papers where the model fit in terms of the CFI and the TLI is at least 0.90. Finally, you have the SRMR, the Standardized Root Mean Square Residual. This works in a similar way to the RMSEA, so you will want the value for this to be as close to 0 as possible. Once you have checked that your model fits the data, you then have to look at the effect sizes, and in fact this feels like the fun part. Here you have to ask yourself a few questions. Do you have non-significant relationships? And if so, were they part of the theoretical model? If they were part of the theoretical model, you will probably want to keep them in because you're making a point that a relationship does not exist when perhaps an opposite relationship between other variables exists. If they are not part of the theoretical model, you can take them out. In SEM, the principle of parsimony is very important. This states that when you have multiple models that fit your data, you should always choose the simpler one. Another question you should ask yourself is, do you have any strange values? These are known as Haywood cases. So for example, correlation coefficients can go between -1 and 1. If you have a correlation, say, of 2.5, that is a Haywood case. It is possible that your model was misspecified, and because of this, the correlation between those two variables was overinflated. So it's always important to make sure you don't have any Haywood cases in your results. Finally, you will want to see whether your hypotheses were confirmed and to see what your findings are in order to report them. However, most often, the first model that you attempt will need to be revised. So here you have two options. Either you take paths out or you add new paths. Now, how do you know if you should take paths out of the model? First, you check if you have any non-significant relationships, and then you make sure the theory allows for their removal. How do you know if you should add paths into the model? Well, MPlus will give you quite a bit of help here. In the output, you can request to receive modification indices, and in that section, you will get suggestions for what other relationships you could specify. However, you have to be very careful because MPlus might give you suggestions for things that do not make sense, like for example a regression path from something that occurs in the future towards something that occurred in the past. Also, the modification indices only give you suggestions for paths between variables that you have already included in the model. So it will not give suggestions with regard to adding new variables into your model. When you use modification indices, it is also very important that the theory allows for it. So as you can see, the theory is very important in SEM. In fact, for most part, SEM is used as a confirmatory technique, and this is one of its strengths. However, when you revise the model, you immediately step into an exploratory framework. So this means that if you have revised your model, when you write the conclusion section of your paper, you will probably want to tone down your conclusions a bit and perhaps even mention that this was a revised model, so that other researchers know that for the most part your model was theory-driven, but to some extent it was driven by the data. So in sum, the SEM process has multiple steps. You first have to specify the theoretical model, then you have to apply it to the data and check if it fits. Then you can check the strength of your relationships, and finally you might revise the model until you reach the final version. Thank you so much for watching, and I'll see you in the next video.